Hello, 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 hello. Today we're looking at a Powerfence Medal 500 electric fence security unit. Not just for keeping your cows in place, but this has the ability to trigger alarms and so on. And the complaint is it doesn't work because it was hit by lightning. So I'm not going to plug it in. If it's been fried, we don't need to encourage it to fry anymore. So we'll just dig right in and see what's going on. A bit of info on the back. What do we got down here? 500 ohm for 300 microseconds is 5.7 kilovolts, or 2.5 seconds, 50k ohm, 8 kilovolts. I don't know how that ties in, if it's an option or if there's two runs of fencing wire that you can have running it, or what have you. Looks like it might even be made in New Zealand, so it's handy. And 12 volts. It does have a backup battery inside, I believe, which is under this cover here, and it feels loose because it rattles. And then up the top end we've got the connectors for the phone line, alarm system, what have you. Let's start by inspecting the loose battery. Probably disconnect it. I'm sure it's completely dead and has no capacity and whatnot. It's been sitting around for a while. Well, it may have some capacity. It's been left unplugged, so there's been no drain on it. So a quick check of the terminals. 6 volts. Well, 6 volts is pretty depleted. I'll put it on charge, see what happens. Not holding my breath. Alright, 6 screws around the edge. You might think that being a security device, it might have security bits to stop people getting in there, but they're plain old Phillips screws. So now I guess that should just lift off, and it does. And we can see we've got a flex attached here, so we don't want to damage that. Actually, it's a same sort of ribbon cable that you'd see in say your old IDE connector. There's no can I pop that off? See if I can unplug that. Oh yeah, that came off easy. Might smell a little burnt as well. But it looks fine on the top side. Picking, this is our step-up transformer and one large storage capacitor. What value is that? Does it tell me? Stickers upside down. 20 microfarad, 1200 volt DC. So, yep. I don't know if it's... Oh, I'm pretty sure it won't have any charge in it. Like I said, it's been sitting for a long time unused. But it certainly doesn't look charcoaled or anything on the back side of the board. So let's continue disassembly and see what's on the other side. So the way it's been assembled, you can see down through the hole, that's the binding post, one of the binding posts on the top side, with the nut holding it in. There's a metal connector that comes up and it's soldered onto the board here, so we do have to desolder all 4 of those to release the board. There's no way we'll get to undo the nut as it sits. Yeah, it looks like it. I don't think we could. There's nothing to release on the front side to pull all those binding posts through with it, so we'll desolder those. Just going to take a bit of heat. Oh, you're gonna laugh. You're gonna laugh when you see what I didn't notice. Here it comes. Here it comes. Anything under there to attach to? There's another plug under the bottom for the key switch that we're going to have to bypass because he hasn't got the key. Alright. Look at this. They were just spade connectors pushed in. We didn't need to desolder them. We just needed to pull firmly. That's awesome. So looking over the board, there really isn't a whole lot going on as far as damage goes. Everything looks intact. Nothing is black and charcoaled. There's only one thing that I can see, and that's the fuse, which has completely blown apart internally. So it's had a full short across the mains input, basically has caused that, given the how destructive, how well destroyed this is. So yeah, it's you can't see through it at all. It's gone with a hell of a bang. So what will cause the fuse to blow like that, you might be wondering? Well, what have we got? There's a MOV for surge protection on the input, possibly some, what have we got there? Bypass capacitors there. They won't have done it, but the MOV, now if the MOV has gone short, it's across, no, that's before the fuse, so it won't be that. So then it comes in through this inductor, and then into, where's our bridge rectifier? There should be a bridge rectifier somewhere here. There's some surface mount diodes on the back side of this board, which is your bridge rectifier, feeding this capacitor. That'll give us about 400, just under 400 volts. And there's a, what have we got there? Couple of, that's our, I'm going to say our switching regulator, without looking at a data sheet. Though it does have 4 pins. We'll be switching across our transformer, giving us, I'm going to say 15 volts out, because it says there's a light here that says 15 volt OK. And possibly a 15 volt rail, and possibly something a bit more. Oh, maybe not. This cat's rated at 25. That's probably it. And from there, our secondary 15 comes up further up, and is switched across that big blue, what's hiding that transformer under that big blue case there, to generate our high voltage. So there has to be a short on the input side to cause the fuse to blow like that. And as the bridge rectifier's the first in line, that's where we'll start. So here's our bridge rectifier. The main's coming in through to here, and then we've got our AC input. Where is that going? I think here and here, and then our DC output here and here. So anyway, since we don't really need to know that, we just need to know the diode orientation, and they are 2 with the bottom one's anode on the left, so we measure across that one. We've got 0.6 of a volt drop, 0.6, and we'll switch the leads, and we get the top one, and 0.6, 0.6. So that's interesting. What sort of resistance do we have across the main input capacitor? Negatives on the bottom. We have 27 ohms. That should be a lot higher than that. So 27 ohms, 240 volts, that's 8 amps, although fully rectified. What's our fuse? Fuse is only 2 amps, so that's why that's gone. So why do we have such a low resistance across the secondary of the input? So it's probably not this. I have yet to see one of those fail. It's probably our switching input controller. So there's really nothing much across that, because all it is this switching across the winding of that transformer, which it shouldn't be measuring that until this switch is on, so it could have an internal short. So we'll remove this and see if the short goes away. I just found out that the main cap, output cap and transformer just unplug. So that's handy, makes the board a bit lighter and easier to work on. Give it a wiggle. And no, I was wrong, this is a 6 pin regulator. Switching, one leg, doesn't want to let go. There we go. Alright, and that is a TOP247YN. It's also riveted to the heatsink, so if we do have to replace it, I'll probably put a nut and a bolt on it. And our reading across the input cap is now, look at that, 30 something megohm. So I think we can safely say the switching controller has shat itself. So before we go ordering parts, it's probably a good idea to see if the rest of this thing works. It could be fried. The microprocessor could have taken a hit. Anything's possible. So let's connect 12 volts to the backup battery input and see if it still operates, because I'm picking. That's how that should work. Oh, yep. So let's just have a look at the. Excuse me. Just gonna have a look at the where the battery attaches. It comes in here through a fuse, off to this resistor and straight out to the main circuit. So even though we have a 15 volt output, it's actually happy with 12. The 12 is going direct. The 15 volt, if I had to say anything about it, is possibly charging the battery. That would be better. It's got a 5 volt reg there, 7805. Yep, so that's a 7805, and that's going to be feeding, that comes off down to our micro down here. So let's stick 12 volts on there and reattach the front panel. And do I put the high voltage transformer in? The output's certainly unloaded, so to speak. There's no fence attached. I think I'm going to leave that off for now. Let's just leave that off so that it's not able to form a high charge. On second thought, it is still able to develop a good 1000 volts at least. It looks like this switches across this transformer as an initial step up, and then it goes across the bigger transformer as the final step up, because that sticker said it was like 3 or 5 kV, so 1200 volts is not going to cut it. So I probably need to put the cap back in, and at least to absorb whatever charge is being created initially. Oh, I just heard a spark, but I missed it. I was turning the camera on. So we've got the lights flashing down here. I'm not sure where it's developing a charge yet. Or if it's going to do it again for me. Okay, in my brief experience with electric fences, you do normally hear some sort of noise coming out of them. This wasn't. This was just like that, just a repetitive ticking noise, and then the alarm went off, the little buzzer here, which is a good sign, because that means the microprocessor is working as it should, and detecting that. Well, there's a key switch here, so as soon as I bridged that out, it turned the alarm off. That came on after a few seconds, along with some flashing lights. So I think this will work quite happily once we've replaced the switch mode controller, and it should be a good little unit again. Although I won't be putting my fingers across it to test it. Yeah. Okay, I'm going to order those parts, and we shall continue this in a couple of weeks. Not that you'll notice. Some brand new switching regulators. Hopefully they're good. They should be, but I've got 5 of them, so there's got to be one good one in the pack. They certainly look new. They don't look like they've come out of something else, so that's a good start. I might have to straighten up some of the pins, but that piece of cake, nothing doing, and I guess not too static sensitive, as they're just thrown in a plain plastic bag. Now we have to get the old one off the heatsink, which is riveted on, and that'll be easy enough. I'll just take it with a drill, I think. Should probably put it in a vise. Might save my fingers if it grabs and decides to spin around. I don't need to lose fingers. I'm already getting sick. There we go. Just rips it clean off. Throw that in the rubbish, and hopefully it'll just pop off this side. Hopefully. Oh, ow. Okay, a little bit of compound on there. Too easy. Poking around in ye old box of nuts and bolts, I seem to have found a suitable match in the form of a screw with a captive washer and a little nut that happens to be the same thread. That shall do just nicely. We'll find a bit of the old thermal goo. I didn't really put a lot on here, so they can't figure she's going to get very warm. We'll pop a little bit on there, top it up. nice and tight. Righty ho, where were we? Get that off there, get rid of that. So all our holes look cleaned out. Let's see if we can't line these pins up. Almost. And they all appear to be protruding enough. Not quite enough grunt for the anchor pins, which are being dragged off by the heatsink. And give it a clean and she's good as new. No worries there. And as for the fuse, well, I've only got one, so let's hope this works. So we should probably do a couple of quick measurements just to double check that we're on track and it's not going to blow another fuse on us. What can we check? Let's see, how about we'll go resistance across the input to this, so across this main filter cap here. And we had, from memory, we had a low resistance last time. Oh, of course, I'll just cover the screen up so you can't see it, that's handy. And now we've got, now I think there's a bit of a coating on here, so I'll make sure I pierce through that. Yeah, meter's working. There we go. 40 odd megohms, coming down, but it's not low. It's not gonna come down to something low, not at that speed. So that's good. On the other side of our bridge rectifier there, perhaps. No, sorry, on the what about on the output capacitor? Was it 15 volts line from memory? And that one will be that one and that one. We have a bit of a washout on the screen. How about put some light on it? There we go. Yep, not a problem there. 3k ohm climbing. You might remember we unsoldered some of these tabs that locate to the terminals on the front, so we need to reattach those. So hopefully these lights will light up and it might even beep for us, and hopefully we don't get any stupid arcing going on across here, but it's certainly not going to jump to anything nearby. It's not enough potential to do that. I'll just keep my hands away. Alright, here we go. 3, 2, 1. Huzzah! Now, so the constant beep is there's a key switch, and I guess he might buy another switch, or he might just bridge it out, but there is a key switch that needs to be set, and I don't know exactly what its intended purpose is, but that's why it's beeping. So, well, that looks like it's working. That's excellent. Another nice easy fix, and hopefully that helps you with any, I guess, power supply troubleshooting that you're working on as well. Thanks for watching.